Welcome back to Archean, episode 5 of season 1 playthrough. And in the previous episode, we went for a little aluminum mining trip and came back and hooked up the batteries for recharging. And here we are. So we're going to make a few changes to our mining vehicle. Kind of check out the battery here, looking around what I'm going to do here. So first we're going to drop this battery, lower our center of gravity a little bit, and I don't expect any long trips anywhere. So wait for that battery to charge, and we'll put the battery here for now. And once the other battery's charged, we'll just recable it. And let's make some ailerons. Check and see if I had any. Make 4 of those. And we need 2 tilt sensors. So this is going to be to try to dampen to greatly reduce the number of rollovers and flips. And we'll just put them over the wheels. It's good as place as any, I think. I put these in the wrong spot. I'm going to have to move those. Making them 5 blocks high. And I get 5 out like the other one. I look at it and go, why? Why doesn't that go as far as the other one? It's 5 like the other one. And then I realize I put that in the wrong spot. And where did my ailerons go? Right there. And we have our tilt sensors. And not sure if it's better to have positive up or negative up. Not sure what the convention is, what people use, but we'll go with this. So I assume positive number makes it go up and negative number makes it go down in this configuration. And these will be all connected to the router, so we have to give them a name, and we use the same convention, if I can spell aileron, as the wheel. So we'll have aileron, front left, front right, rear left, and rear right. Alright, now I'm going to cable all this up, and yes, if you hit F2 and go into drone mode, you actually able to fly inside the block, and you can totally hide all this wiring. I'm just not getting that fancy. Just gotta kind of slam all these together real quick. Oh yeah, and I also want to wire up the anchor so I can use the toggle switch. So two reasons. One, I use the toggle switch from the seat to turn it on. And the second, to have it automatically engage if I turn on the mining tool. So just in case I forget to turn to anchor before I turn on the mining, it'll automatically engage. Now, whether you're actually in a good spot to engage is something else. And we have to name this since we're going through the router. A really creative name called Anchor. And we need tilt sensors. So we're gonna tilt for the X direction and the Y. So this is the Y, because Y goes front to back and it rotates on that axis. And this is X. X goes left and right, so we're gonna rotate. If you imagine a line going between the wheels, that is your X direction based on the seat configuration. And so this is our X, and we'll look. These I had them ports over here. I guess I don't. They're all filled on this side, so we'll have to route it around the other side. Gonna run out of ports on our. Okay, so we'll stick this, lock it down there, and we'll put this. So we'll have on number 6. We'll have X. And then under 7, we'll have our Z will be on 7. And just going to double check. Yep. All right, so this should be all the hardware changes we have to make. Yeah, remember my suggestion of might as well get some printing construction going on while I am doing a little programming. Let's make some more magnets. And the diode's kind of low. And LEDs, which I believe take a long time to make. Okay, so we got a bunch of stuff we need to do here. So the things we want to do is we want to support adjusting the ailerons based on the tilt, so we can reduce the probability of rolling over or flipping. So we define the ports that are connected to the computer. We need to get the tilt information. Yep, that's a bad comment. Not sure why I keep typing tile instead of tilt. And yes, the word Tyler should be tilt in the comment. So I figure I display the tilt value. We're going to shift all this stuff down a little bit. I first thought I'd have one line for X and one line for Z. Then I decided, well, I can put them both on the same line. This results in a gap, but that's fine. It's actually having a gap between these numbers and the ore composition is probably makes it look a little better. You think I need to take a touch type or refresher course? There's quite a few of those around. Just sit there and repractice, speed it up a little bit. So the other thing I mentioned in the last episode is to render the ground composition in percentages and not in you know, these values. And believe it or not, this is, I think, one of the first functions, at least functions I've written in a while. I typically don't need functions, but I'm kind of bringing up the wiki up and going, how do I write functions again? Bounce around multiple programming languages, so sometimes it's kind of weird. I was getting ready to type in var, but we don't need to distinguish that since you can only pass variables. Okay, so a quick peek at the wiki, and we just typed the name of the of a function, colon, and the type. And this is going to be text. I couldn't think of a better name than raw. Oh, yeah, let's call it that. Okay, so percent is, we'll take the raw value, we'll convert that into a number, multiply it by 100. And this returns a number. Yes, I forgot the return statement. Actually, some languages, I forget which one it is, the last, the value of the last statement or expression is automatically returned. So you don't need an explicit return value. I forget what language that was. But in this case, we need a return value. We'll get a warning. And or won't. Actually, I don't think we get a warning. I think it just doesn't work right. I think by default, returning 0 or something, or actually, I can see between the I'm just not getting a valid value. So it's probably should get a error. And here it can't return a complex expression. So we have to set that and return the variable. I can spell percent. Okay, so now you look up, you see in the computer monitor behind the editor, we're now at 25.0%. And we're just going to fix the rest of them up. I'm going to speed this up by 5x. I'm just editing all this stuff, so this little block here. Okay, so we got better numbers. They don't really line up very well, so now what I'm doing is I'm putting in the anchor switch. So anchor on, that'll be the next switch is 4. The number of switches 1 through 4. I did that because if you were looking at the switch and you ask somebody what's the last switch, they say that the 4th switch. Internally, it counts differently. Looking at where to put the this stuff at. All right. So if the drill is on, we want to automatically put the anchor on. And then we want to set the anchor. The order doesn't really matter because it's an event-driven simulation. But we'll just do it here. Like this. Okay. So if you manually turn the anchor on, and the drill's off, then it'll turn the anchor on, drill off. If you turn the drill on, the anchor comes on. And adds a little bit of safety. Also makes it a little easier if you just want to stop someplace and flip on the drill. You can just flip it on and not worry about the whole extra switch anymore. Alright, so just double checking. And you have the anchor. So I'm just changing the formatting a little bit so it kind of lines up better. So apparently that doesn't work. You can't, I was hoping it would do, having, setting him 00.0 would have 0 space dot 0, but that formatting option is not supported. Now the one thing I don't put on in this version is the auto lock, where if an ore hits a certain threshold, we just turn the anchor on. Actually, might as well turn the anchor and drill on at the same time, be done with it. Although we did that, then we couldn't probably turn it back off. So no, we'll just turn the anchor on automatically if we hit that. That actually causes a problem because if you hit a spot, like say you have it set for 20% and you hit the 20% and you turn the anchor lock on, you won't be able to leave until you change the code. You'll be stuck. So I guess we need another switch to enable that mode. So if we add that mode, have a switch to enable that, when you turn the switch, turn it back off. Okay. So for the aileron settings, we've got two inputs. We have the X input and we have the Z input, and we want to combine those. So what I'm going to do is I'm going to set up a bunch of a variable per aileron. Now, if you only have one tilt sensor, you can make this a lot more compact. But, both rolling and flipping are both issues. So first we're going to pull in the X tilt. So the X tilt is like, flipping over. And we'll just the front and the rear have to be opposites. So we'll just do this for now, and we'll check it in a minute. We'll comment these out, so we're only focusing on one tilt sensor at a time. And we have to set each aileron. And as far as I know, it's only got one channel. We'll set that. We'll duplicate this. Rear left, rear, and change these to match. And then eyeball it for a minute to make sure I don't have a typo. Oops, didn't want to do that. So now I'm gonna get hung up on my base here. If a guy was sitting in the seat, so trying to still hung up on my drill there. Oh, also I'm still connected to the base for power too. And the battery's charged fully. We're consuming a little bit of power to run the computer. So we'll disconnect from there. Plug it to there, start charging that one up. Now if you have a docking port, I could dock it with the base and have it auto charge once it's docked, and then just undock it to pull off. So you can do this without having to recable it. So what I'm going to do now, I'm going to test how well the tilt works. So what I'm going to do, I'm just going to force it by putting a block in the front, and it will pop up. And this is weird. I go, okay, that's weird. It should. Why isn't the physics kicking in? So this is apparently a bug. It somehow didn't initiate. If I didn't register it as moving, it just got repositioned, but since it's not moving, it doesn't need to apply physics. And then when I stand on it, and then physics kicked in and it rotated. All right. So now I can look at and I'm being stupid here. Okay, so that, if it points up, that's what we want. We want to point up, because if it points up, it's going to push the air up, which forces the front end down. But that doesn't seem to be a lot of movement given the tilt. So another factor here, which I do not account for, is speed. So the faster you're going, the less control movement you require. The slower you're going, the more you're going to need. And this is something I do not account for in this code. And so what I'm doing the bare bones simple version of using ailerons to prevent tipping and rolling. And you can overdo the system. You still can roll it and flip it if it just gets beyond its ability to react to the control. On the side, the ailerons on the sides are they're not that far apart, and it's possible, given the size of the vehicle, actually like maybe more than one just aileron per corner, maybe 2 or so, or a little more. So what I'm doing, I'm adding a little factor, a little K value for each one, so I can apply a little more. And once again, I said this should be based on, it should be a K based on speed. So it should be like, I should take the speed, multiply it by K, and then use that, or yeah, multiply the speed by the K, and then K multiplied by the tilt, and then that should give me a speed specific action. So at 0 speed I should get maximum. Since we're not going very fast, we should have more tilt. Okay, so this will push the front down. All right, because the air hits it, it goes up. So the air goes up, and the force pushes down. And the back are reversed, so they should pull up. Now, another problem I have is that, like right now, we are pushing the front down, but we're pulling the back up. And if the back is sitting on the ground, we don't want to do that. So basically, if a wheel is on the ground, we should not apply. I'm just thinking about this as I'm reviewing this. If a wheel's on the ground, we shouldn't apply any aileron. And the other thing is that maybe when we're level, we apply downforce across all the ailerons just to try to keep it pushed to the ground, like a spoiler on a car. Now, when I applied it on the side, it immediately popped up this time. So that's interesting. Okay, buddy. So I'm trying to rotate it to one side so I can check the roll. See? I did a little bit, and it tilted. If I do it a lot, it just lifts it. I wonder if it's almost a feature, so you can lift something up and build under it. Now if I drop on it now again, it rotates. All right, so now right now in the code we disabled the anti-roll part of the code. So anyway, back to some of the other scenario which I'm not covering in this, is that there's you could probably spend another hour or so just kind of messing around with some of the more advanced features. I'm not doing it right now. It's going to keep it very simple. Just because it kept rolling over all the time, in the previous videos, I figure I play around with this to kind of show off the technique. But there's a lot more I can go with this, and I think the next episode, I need to go find gold. So the next episode will be about a primitive ore scanner from scratch. And to try to locate gold, and then once you have a location for gold, then we'll work on a submarine. So next episode, we'll start on the ore stuff. Scanner, if we have time, we'll start on a sub. In the beta branch, there's been improvements for submarine usage. So once I have a sub ready to go into the water, I will kick over to the beta branch to see how that works out. Assuming it hasn't shipped by then when I get to that point. Okay, so I think I got everything tuned up and they'll operate as expected. I think there's definitely a lot of bugs. I think the applying the ailerons based on if a wheel's on the ground or not should factor in. You could argue that I should apply, if the wheel's on the ground, I should always apply downforce to that wheel, trying to keep it on the ground. And then that way, if the front lifts up, the back is always just, right now, that if the front lifts up, the back will lift up too. It will push the front down and lift the back. I think that's an error. I think the front lifts up, I should bring the front down and maintain keeping the back down. So basically, they both to be full down. Okay, so definitely room improvements. It helps a bit. And the K value, see that back lifting up when it shouldn't. Yeah. Well, and then once it lifts up, it angles up, then it forces it back down again. What I really want to do is that, say it really hops off an edge, it should like fly level flight like an aircraft, like that. So it just kind of levels out. Interesting that the back went down first. Now it could be the center of gravity is to the rear. Right here, okay, we just don't have enough oomph. They're going pretty severe, but there's just not enough aileron there to force that front end down. Now here I'm showing that I can reset the orientation without getting out of the seat. I mentioned that in the last episode. Okay, oh, we got 0.1% aluminum. Okay, so I'm just trying this out. This is dumb. This is gonna just make it go worse. We'll just see how, if we do the opposite and get it wrong, what happens. It doesn't always kind of playing around. See, definitely just force it around the wrong way. So the other thing too, the rolling aspects kicks in. So you got two values kicking in at the same time. And the so one interesting experiment is just kind of keep mucking with it and get it to the point where it just really can't ever roll over no matter what you do to it. And I think that requires a number of changes that I discussed before, and probably additional ailerons, maybe even mini wings on it to help a little bit. Sort of training wheels for building an aircraft is just put little wings on it and just go really fast and to start hopping into flight. Now the roll does pretty well not rolling. So I want you to watch this in slow. Here we go. So he's trying to pull that. So here, okay, it's pulling the front that side down. The roll works really well. Yeah, I think if I yeah, so here we are. We lifted that. Oh, see, it's too much. We adjusted. Okay. So definitely improvement, definitely better than before. And I really got to push it to really flip it now. So here we go. Okay, it's pulling it, trying to get that slide down. Yep. Okay, it did. It's like the roll is pretty good. It's just the flip is not where it should be. And I think, as I said, if a wheel's on the ground, and I said I probably should just provide, if a wheel's touching, then kind of push it down a little bit. And that'll be the override. So do all the calculations, and then if the wheel's on the ground, always do a little bit of, I guess it's positive to push it down a little bit. That'd be the default. And see how that does as far as work, because I think I'm purposely moving the wheels off the ground, because the ground can be, if you're going up a hill, then it's totally going to confuse the logic, because the wheels could be all touching, but as you're going up, it's going to try to lift the rear wheels off the ground a little bit. But anywho, this kind of shows you some of the really interesting things you can do with the physics and coding stuff. For the submarine in this episode is going to be far more advanced than the previous series. That was a complete disaster. Plus, they're making all the physics changes for underwater, so this should be really cool. So I'm going to actually build a pretty good sized sub and all that, so we can hunt aluminum. All right, so we made some improvements. We tried out a very basic anti-flip, anti-roll. I think there's a number of things to make improvements to that. And then until next time, see ya.